Nuclear fusion is the process by which light atomic nuclei merge to form heavier ones, releasing an enormous amount of energy in the process. This is exactly how the sun and other stars emit light and heat. In laboratory settings, fusion usually involves the merging of hydrogen isotopes, deuterium and tritium, into helium and a neutron. The energy released in this reaction is millions of times greater than that of chemical processes like burning fossil fuels. The potential of nuclear fusion is hard to overstate. Virtually limitless fuel, deuterium can be extracted from ordinary water, and tritium can be produced from lithium inside the reactor. Environmental cleanliness. No greenhouse gas emissions like those from coal and oil, and far less radioactive waste than conventional nuclear fission. Safety. The reaction shuts down if conditions become unstable, no risk of a second Chernobyl. So why aren't we using it yet? In theory, fusion sounds perfect, but in practice, it's one of the most difficult technological challenges in human history. To initiate the reaction, conditions similar to the core of a star must be created. Temperatures around 150 million degrees Celsius. Materials melt, magnets require superconductivity, and the system must contain scorching plasma without letting it touch the reactor walls. This is exactly what the International ITER project in France is working on, aiming to become the first fusion reactor with a positive energy output. Its launch is scheduled for 2035. Meanwhile, dozens of startups and private labs, Commonwealth Fusion Systems, Helion, TAE Technologies, are already developing more compact and accelerated solutions. The arrival of controlled nuclear fusion will change everything. Energy independence. Countries will be able to power themselves regardless of oil and gas supplies. Accelerated technological development. Cheap energy is a catalyst for the hydrogen economy, water desalination, fertilizer production, artificial intelligence, and space exploration. If controlled nuclear fusion becomes commercially viable, it could ignite a new industrial revolution, comparable to steam, electricity, or the internet. Imagine a world where electricity costs are close to zero, where energy production is unaffected by time of day or weather, and infrastructure can be scaled without dependence on coal mines, oil platforms, or gas pipelines. This will completely redefine supply chains, logistics, and industrial design. Factories could operate in remote regions. Agriculture could use energy-intensive greenhouses in deserts and tundra, and rare earth metal processing could happen on-site, with minimal environmental impact. The very notion of an energy crisis could become obsolete. At the same time, fusion energy could trigger the rise of civilizational engineering, directions that were previously impossible under current energy constraints. For instance, large-scale desalination of seawater for irrigating deserts, building cities in extreme climates, removing carbon dioxide directly from the atmosphere on an industrial scale. It could enable terraforming, the construction of space stations with artificial gravity, and possibly interstellar probes propelled with acceleration beyond what chemical or even fission-based propulsion allows. Forecast: nuclear fusion in the 21st century, 30s. Emergence of the first demonstration reactors with a positive energy balance. Breakthroughs in superconductors and plasma stability, 2040s. First commercial fusion plants begin supplying power to cities. Fusion energy becomes cost competitive with solar and wind, 2050s. Widespread adoption of fusion energy worldwide. Fossil fuels begin to be phased out. Mobile fusion reactors deployed on ships, Arctic stations, and in remote regions. Preparations for integrating fusion technology into spacecraft for missions to Mars and beyond. Nuclear fusion is not just a scientific challenge, it's a civilizational transition. If the 20th century was the age of oil, the 21st could be the age of stellar energy. And perhaps it is this technology that will give humanity the chance to survive, thrive, and one day venture beyond the boundaries of the solar system.